So good morning, everyone. Thank you for bearing with us while we had some technical difficulties. It's my pleasure this morning to introduce Dr. Ajay Kothari. He is president and founder of the Astrox Corporation, an aerospace R&D company located in suburban Washington, D.C. His PhD and master's in aerospace engineering are from the University of Maryland, and his bachelor's in physics is from Bombay University. He has over 45 professional publications and was awarded a National Merit Scholarship. He has been principal investigator on more than 30 Air Force, DARPA, and NASA contracts, including hypersonic scramjet vehicles and reusable rockets. He has been invited to speak on aerospace subjects by many entities and interviewed on television shows. His articles on space-related topics have been published in various news outlets, and he's a member of the Screen Actors Guild, having acted in Law & Order, Unsolved Mysteries, The Wire, and more. He is also an artist, having exhibited at the New York Art Expo in various galleries. Please welcome Dr. Ajay Kothari.
First of all, thank you all very much for coming, and thank you for bearing with me for this problem of, so to speak, technical difficulties that we are not able to start right on time. But I guess I'll have to hurry up, so I will hurry up. So my point here is that the space exploration that we are all very excited about and we all want to do, and we want it to be prolific and successful, etc., those kinds of things. Why? Why do we want to do that? And a lot of people, obviously, non-space enthusiasts have been, pointing fingers at it and all that. And so what I have sort of realized, I wouldn't say discovered or anything, but realized is that there is some other reason why this is an extremely important, and Sherry called it inevitable, and I will call it the same, inevitable, extremely important thing that we should all, not just us, but the whole world, the whole earth needs to be, excited about and contribute to it also at the same time. So with that, we go to the next slide here. Let's see here. The page down. Oh, there. So, does anyone know how to do a page down here? Show. We do the page down.
Let's see here. I keep trying to click that. There we go.
Yeah.
So then from here,
Oh, from
just
here. Oh, there. Yeah.
there you
Okay.
go.
Yeah. So just before this, we had a plenary session about women in space and what is happening these days, and I'm very happy about that and very supportive of those activities and other activities also, which I'll mention in a second. But my point is that I've been going to this space-related and aerospace-related talks, papers presented and all that, and every time it has always been, the big military-industrial complex type of people who come and talk, and it's always been boring, really boring. And it's, their ideas were just, of a certain type. Now we have other viewpoints which are coming into play because we are including more ladies, women in this. And so that's a very big plus for me. And I did say earlier that, artist, author, et cetera, but that was not to talk about me in a boastful manner or anything like that. It was just because I'm trying to connect that with the space and all that, with those other elements. And so that was the reason for that. And this is a painting that I created there. So this here you can see a woman, and I'm going to walk away, but that should be okay. So we're going on Mars, and that's the deck. But the idea is that it's an abstract, obviously, but the idea is that when that happens, there's not going to be any disturbance of topology on Mars or any other planet, and this is obviously my viewpoint. Fine, but it'll meld into the topology and meld into whatever exists there, and so that will be very, very interesting to do, very useful, very nice thing to do. These are some of the other paintings that I've done. And again, I'm trying to here make a point that Earth itself is very important. The life forms on Earth, all life forms on Earth are very important. And yesterday there was a talk by Dan Hawk yesterday. I don't know if he's in here or not, but anyway, I feel very strongly about something else, which is also shown here, which is that in this country we have really ignored and treated Native Americans kind of badly, and so this is my painting on that. It's proud, ignored in America, yet proud tribute to indigenous Americans. And of course, the one on the right is a nebulous dance, and one on the left is Chesapeake Bay. That doesn't matter. And this is my favorite, a lion, majestic thing. Okay, so now why? All right, so my presentation here is not supposed to be taken as a touchy-feely one, even though I talked first 2-3 slides were touchy-feely ones or something like that, but it's not supposed to be just simply touchy-feely one. The arguments are based on science and present data. So it comes from the heart too, for the love of all life forms on Earth. But it is not and should be confined only to space enthusiasts. It should not be. There is something more, something much more. Here is how we can make a science-based case to the whole world, not just US public, but the whole world. And what is that? Okay, so now, why space exploration? So this is why should the whole humanity pick up this baton and run with it? The answer is a deeper and perhaps more profound than simple arithmetic of how space has brought us. People talk about this, NASA brought us Tang, brought us this, brought us this. This is much, much deeper than that. Whatever it is that I'm going to suggest here. It's more profound than us getting there before some other country occupies part thereof, for lunar resources, or potential minerals for someday from asteroids, or us remaining number one. And it's even more profound than all these 30s and 40s and 50s movies that I see from Hollywood about human interactions and all that, which I like a lot, but I think it's even more profound than that. It is really, really quite serious also. Okay, it's through the Drake equation and Fermi paradox that it has gone too far, very deep. Okay, so now I was born a son of a farmer, poor farmer, back in India a long time ago, obviously. And my father would, we were sort of watching Apollo splashdowns, et cetera, in the 60s. And my father, it's in the middle of a jungle, and there is a tiger living nearby and all that. And so imagine this. Tiger is walking through the jungle, the farm, and my father and we were, listening to an old decrepit radio there. We didn't have TV. Didn't have money for TV, but didn't even have TV channels at that time. Listening to the radio around the campfire with the farmhands and us children and everybody, and we were listening to the splashdown of Apollo at that time. We were so impressed, so aghast at what this country could do. It landed within 3 miles at that time, 3-mile radius of where it was intended to land. So we were so impressed. And of course, and that's not the only reason why I was interested in space and came here and studied and all that kind of thing, became rocket scientist. But it's really quite something. So I came here, and here I offer a thesis to how, why, and how space exploration endeavors are not just field of scientific thinkers, but many others, and we want to bridge that divide between us and those other people who are not too supportive of us. So there are a couple of dots that I'm going to connect, and we are starting with the dots now. So these are the 5 different extinction events that have taken place on Earth. Ordovician, Silurian, Devonian, Permian, Jurassic, Triassic, and of course the last one, as we know, where the dinosaurs were wiped out. 75 to 95% of the species were wiped out at that time. Every time after all those species were wiped out, new species were created, and the new species, hundreds of, millions of species, hundreds of millions total, billions of species were created. But the interesting thing is, out of billions of species, not one of those species ever thought about clothing themselves. Not one. Not one of those clothing themselves to protect themselves or something. Why? Why was that the case? That is incredible. Not one. And now, of course, and this is kind of a joke here, but now we unfortunately do this type of clothing also, which is Gala, Met Gala, Cardi B is the name of the person. Anyway, so are humans superior because of that? No, we are not superior. It just simply means that we have been given a fantastic responsibility to do something, to take care of this. It just means that we have been given this tremendous responsibility, whether by God or believer among us, or by happenstance for atheists and us. We have to do that. We have to take care of this people and Earth. Now the other data point. The other data point is the Drake equation. So we have a Drake equation with 7 terms, as you all know. And the 7 terms are made up of the fraction, how many percentage, what percentage of the planets were able to come up with life, how many with higher form of communication, etc. When we put in the numbers, basically, we come up with a number which Dr. Pascal Lee, who is one of the speakers here, says is a total of 1, which means that in this galaxy, we may be the only one. We may be the only one with the ability to do this communication, whatever it is that we are doing now, or we could be more, either one. So this is really very scary. It could be very scary, but it also gives us a lot or lack of responsibility. We have to take that responsibility. And that responsibility is very important for us to realize. So then the Fermi drops in, and you might know about the Fermi paradox also. So the Fermi drops in and he says that, where is everybody? So if we have millions of people, and that number was, at that time, was hundreds of thousands or millions of in the galaxy, where is everybody? So that means that nobody has communicated, where is everybody? Nobody is here. Nobody else is here. So we have to, either way, in either case, whether it's 1 or it is more than one, I mean hundreds of thousands or something. We have to protect in one case and be protective of us in the other case. Answer is the same. The answer then will connect the dots a little later. So we have to protect and be connect to do that. Not always physically going everywhere. I'm not talking about actually going everywhere and doing things and taking people there, etc. But we have to evolve in this space dimension, third dimension. That's the important thing that we have to do. And that's a third dimension, that's a Z direction dimensions. So far humanity's expansion have been on Earth's surface, wars, expansion, now we must do in Z direction also, which is the philosophical idea here. So all life forms may be completely unique or most likely unique. It's scary. So we need to protect if we are so unique and be protective if we are not. So huge effort is needed in intellectual effort that should include. So that calling for us is a higher calling, I would say, than climate change. It's a higher calling than even human species survival. This is a survival of all life forms. It's a survival of Earth by itself also, but it's a survival of all life forms. So whenever these people make a case about humanity or humanity's survival and all that, I think that they don't see the whole picture. They need to see the whole picture, and that's what we need to talk to them. We need to make them cognizant of that. So the whole huge effort is needed, intellectual effort that includes merit in media of field, from art, which I showed a little bit of that, and I'll show a little bit more later. The point is that all these other humans, they have a stake in this. All other humans, meaning artists and musicians and art and authors and philosophers, we have a stake in this because we are talking about the entire uniqueness of life form of this earth. Uniqueness of life forms, all life forms on those, including roaches, including alligators, including snakes, which I don't like at all. But including all of them, we have to be, it may be extremely unique. And if it is, then that calling is bigger than a climate change calling. And so we have to, and this is somebody else who has done some other paintings, imagination. So I'm trying to bring the imagination also into this picture. The imagination of all people, the artists and musicians and philosophers, and everybody is extremely important here. We need to work together on this. So this one, and so then finally, this argument is not about fragility of humankind that the environmentalists dwell in, that actually is humanity-centric, which is comparatively selfish. That's what I'm saying here. And the argument is, what about our generation that people like, I wouldn't name names, but something, Greta states, what about our generation? That is even more selfish, as far as I'm concerned. We need to showcase this more compassionate and science-based argument to realize the depth of the issue. So all life forms on Earth may be extremely rare and unique. If that is the case, it's not just responsibility of space enthusiasts, it's everybody's. Poets dream and inspire all others everywhere. Authors imagine stories of what and what not. Philosophers type into our mind. Artists imagine what I just showed. Imagine the unknown. Musicians touch the heart. Visionaries. Anyway, I mean, all of those people we need to make a case for all of these people not just for our space enthusiasts, oh, we love to go to space and we need to do this and all that. That's not going to fly. I mean, it can fly, it'll fly, but I think that there's something bigger here, something much, much, much bigger at work, which we need to really expound upon and do. So we must now partner with all these people. Okay, now, okay, so now I'm saying that this is an evolution in third dimension that we are engaged in. And that evolution, we need to continue that evolution in the third dimension, which is space. And that evolution, we have been doing this so far in the 2 dimensions. Space now is allowing us the opportunity to do it in third dimension. And what would happen, of course, is that all forms can be wiped out and etc. But through science done in space observation like Webb, robotic exploration and human reach, all of them, we invariably need the answers about what is happening, what may happen. It is scary. It can be scary. It can be scary. So we have to do all that. This is done in 2 related ways, through the mind, which I just talked about, and of course physical expansion, which I'll talk about next. So next few slides discuss how part of the can needs to be done also. So this portion here, I'm combining this as the dots. How much time do I have? Okay. So now, I'm going to talk technical here. I have been also realizing, trying to living in space is going to require, the thing that will require the most for living in space is energy, bar none. Energy will be the common denominator for everything, food, everything that we want to do. So the highest controllable energy content is through fission at present, or any nuclear power. Thorium and uranium are the only primordial, and plutonium are the only primordial elements created at the formation of stars. They are God's gift to us. Take advantage of them wisely. Their energy content, look at this, is 1 million times more per unit weight than chemical, and 3 million times more than coal. Now, if we can only combine what we need to do, like what I talked about, and also how we do it, and we do it the best way we can, which is through using the fission. We've got it made. We haven't got it made, but we are on our way to something very, very useful for the whole entire planet. So here is the fission. As you can see, 235 is divided by, with a neutron, it adds a neutron to it, and it divides into 2, into krypton and beryllium at this time, barium at this time. And then now, even more useful and important now is this one, thorium. Thorium is a lifesaver. So, of course, we know Thor, the god, Norwegian god, and all that. Thorium here, absorbs in that neutron, becomes thorium-233, and that thorium-233 decays, beta decays into titanium, and then that beta decays again into uranium-233, and that uranium-233 will fission. And when it fissions, it'll create 2 other elements, and it releases the 200 MeV of energy per atom, which is, as I said, 3 million times more than coal. We will not need coal. We will not need other renewable solar and wind and all that. And if they are there, that's fine. But it will not be able to satisfy our needs. So these are the generation 4 nuclear reactors. that are being mentioned, they are being talked about. This is the one which is most useful and best, and that's molten salt reactor that we can create. And how do we do that? So one of the major problems for the present day nuclear is, and we know that people are anti-nuclear, especially the environmentalists, because they are all pressurized water reactors. Pressurized water reactors is not the right way to go. This one doesn't need to be pressurized. Molten salt reactor does not need to be pressurized, works at sea level pressure, so it cannot blow up. It cannot melt down. And it provides you the same amount of energy that the uranium plants have been providing per kilogram. So actually more. So this is the way to do that. We don't have to solve this problem. Why don't we solve this problem smartly rather than throwing the baby out of the bathwater, which is what we seem to be doing. So here, thorium molten salt reactors will solve all of the above. And this is how thorium looks like. Again, 1 kilogram or 1 ton of thorium is equivalent to 5 million barrels of oil. Imagine that. We have 6 million tons of thorium available on this earth, which is equivalent to 30 trillion barrels of oil, and we have only 1.8 trillion barrels of oil in reserve on this earth. So you don't need that. It's a solution. It's a solution for the entire earth. Energy, no pollution, no CO2, no blow up, all that. And then we are going to use this to take us to off-planet use also. Moon has that. The previous slide was showing the moon has that. Now, if we make, this is Nerva reactor on the right-hand side. But instead, if we do it with the thorium, we can get pretty good ISP, 665 ISP, and we can use that to do that. But more than that, we can also use this this is the best option for nuclear upper stage. And you know that Draco, the new program of NASA and DARPA has been started, which is not using this, but it should use this nuclear upper stage propulsion. One of the reasons why it's not being done is because people are afraid. But here, the thing is that it takes 27 days for the nuclear reaction to start. So within those 27 days, you can put up the upper stage. Upper stage can go into orbit, and it'll be completely safe because it's just carrying only thorium to begin with. So this is really it has so many pluses. And so when it makes to Moon or Mars on lunar space, the same reactor can be repurposed for energy. And for lunar dust mitigation also, it can be repurposed for energy. It can be built roads on the moon. And here is how I was suggesting that that for space propulsion, this is Bezos's upper stage for New Glenn that I designed in my company to simulate that. And that can be converted into a nuclear-powered upper stage, and that can then be used. That reactor part then afterwards can be used, repurposed on the moon to do this. So this is really quite possible to do this. And then it can be repurposed for heat, and it can be repurposed for electricity production also on the moon. So finally, in summary, on and off planet, these are the advantages of this thorium that we have. Terrestrially, fantastic advantages terrestrially, and fantastic advantages, not as fantastic, but still very good advantages for off-planet use also at the same time. So what more do we want? Only even majority renewables, solar wind cannot hack it. half or more energy coming from nuclear is the only way. This is for terrestrial. Now, I want to connect the dots here. So, to connect the dots, all life forms on Earth may be extremely unique, and in our galaxy, and almost certainly in observable universe, we know that. It may be a scary scenario, but it means that we all humans have a tremendous responsibility granted by accidental happenstance to protect and be protective of all of them. We cannot afford to mess this up. This means that responsibility, not just space enthusiasts, but also others, also have to lend a shoulder, all authors, poet, everybody, not just scientists. Humanity now has the responsibility to continue the Earth's revolution in third dimension, that is space, and third dimension, that is space, visualization and plans in our collecting mind, and use the primordial elements given to us at the creation to expand our reach physically. So that's kind of the idea here, is to do this for the reason I mentioned and how to do it. So with that, I conclude. Thank you. Questions?
Questions?
Yeah.
Looking at your, can you hear me? Looking at your Drake equation, Fermi paradox, I was reminded of the way we measure our use of energy on this planet on what they call the Kardashev scale. But then I looked at your idea of how we can come together and transcend all of this science and stuff on Earth and love one another and reach out in the arts and science. And so far as I know, we don't have a scale to measure love. I mean, it's what is it, subjective rather than objective. And I'm thinking we need a scale for that. You need to come up with a slide for that, because if we can't measure it, we can't quantify it, and you know, it's not real to us engineer types. So I think we need to somehow work on a way of measuring how we can get from point A, where we're at now, to point B, which is going to transcend all of this and protect all the precious life on the Earth. And that's sort of my observation based on your start into the Fermi and the other mention of with the Drake equation, which I've kind of been mystified by myself as to why we're the only intelligent species that yet seen. And frankly, I don't believe that. I think there are others, but we just, well, we're too stupid for them. It's really that simple.
Yeah. Well, I think that you mentioned about love, and my idea is not really about love between all of us. It's about responsibility. It's a responsibility of everybody, all the other authors and artists and everybody, to shepherd all the life forms that we are. If we are so unique, and if we are not, then to protect them, also be protective of them. Either case, it's a little fluid, I agree, but I think it is still quite important to realize that there is a uniqueness here.
Thanks, AJ, for this presentation. You mentioned there needed to be coordination between DOE, NASA, I think one other organization. I can't remember which department, but
DOD.
How do we do that? I mean, it's got to come from the top, right? So what are your thoughts there?
Well, it has to come from the top, or it has to come from public, either from the top or from the very bottom. We all need to just, get up and talk and convince people in general, and talk about this thing. And we have to make a case to everybody, to writing, I don't know how we do that exactly, you know, and I think some of you are already doing it. I mean, David, I know he's been doing it for a long time here, but I think that it's just really, really, really important that if we are the, you know, if you are unique in that way, and if you don't take the unique responsibility and we just dither around with just simply climate change or what about my generation and all that, that is very selfish, very bad, you know, very selfish.
AJ, you listed under reuses of the molten salt reactor, you listed lunar dust mitigation. Can you tell me what you had in mind there? Can you tell me what you had in mind there with lunar dust mitigation?
Yeah, actually there is two companies. One is X Architecture and the other one is called Icon. They are both working on something similar. The idea here is that using the energy, heat energy, obviously heat in this case, they would melt the regolith and then they'll make bricks which kind of look like this and put those bricks right next to each other and build a pod. And you can build a pod that way, or you can build roads on the moon also that way using this regolith. So it kills two birds with one stone. I don't like to kill birds, but but the idea is that you get rid of that dust and also you use the regolith for doing something very important to take off, you know, to be able to land and take off from Earth and also make roads on the moon later on. This is really, you know, it's very interesting and and these people have actually done some of this work. They have even produced fibers with this, one of the Israeli companies has produced fibers with this regolith type of system. So that's what I'm talking about here. So, yes.
Thank you so much, you guys. I really enjoyed this. Two questions. First, with respect to quantifying love, I think it's incumbent upon engineers with their collaboration, with their planning, with their equations to look at it in the context of love. I don't think you'll ever quantify love. I think it's a bold statement. That's thing one. Thing two, activating these nuclear engines in orbit, is there concern about possible contamination of further contamination of Van Allen belt?
That's a question I haven't answered or thought about. But as far as going into LEO area, ISS LEO area, anywhere from 200 kilometers to 400 kilometers, that can be avoided in terms of contamination that everybody is afraid of sending. Even they are afraid of RDGs, sending the RDGs, you know, to orbit. So far, they've been afraid of that. But it takes 27 days for this to start, uranium-233 to be produced. So if that is the case, take advantage of that. I believe in taking advantage of every weakness, you know, or strength, whatever it is. But in this case, it just really is quite something. It's possible. There are questions and there will be things, but here we are here to, you know, try to address those. Well, what are engineers for? What are rocket scientists for? We will address them. Those are all challenges that we work with. Just like I'm asking the artists among us to address those other challenges. Same thing.
For what it's worth, I'm a musician.
Huh?
For what it's worth, I'm a musician.
Well, so is Tim's son. Very good. Thank you. Okay.
Any other?
Anybody else?
Okay, thank you.
Thank you.
AJ. That was really good.
Thank you. Thank you.
Okay, next we have student